now enter a very short session of question and answers before the coffee break. I'm looking at the chat window. I don't see any questions right now. So I invite anyone who desires to ask a questions to use the chat window. We also have another Q&A session at the end of the next block of talks. I will make just one question then to our panelists. I don't know if Harald Bugman is still with us. If so, Harald, can you hear us?
Yes, I'm here.
Okay. So I will ask a question from the things that surprised me most among all the presentations that we heard this morning, and that's your graph about the end of the carbon overshoot in the increase of forest. So everyone, yesterday in Italy, for example, the results from the last national forest inventory were presented, and so the most important result was that the forests are continuing to increase both in area and in biomass. But your graph and your suggestion is that this increase will eventually end up. So why is that? And if so, what should we do about it?
Okay, I mean, the graph I showed refers to carbon or biomass per unit area. So this does not include an increase in the forest area. It's just the per area carbon storage, which increases very strongly at the beginning of a succession, and then it comes to a maximum, and as the late successional species are taking over, that is going down again. So I know what you are mentioning, that the carbon storage is increasing, is also what we find in the Swiss National Forest Inventory, for example, or in the Bundeswaldinventur in Germany. But the prediction from that model is that this effect will come to a halt at some point in 2030 to 2050, and thereafter there will be a slight decrease. So I don't think that the model result is in any conflict with any empirical evidence so far.
Would that be for climate change pressures or extreme events, or is there any reason or explanation for this expectation?
No, it's just intrinsic successional dynamics. You know, the simulation I showed was not taking into account climate change. It was under a constant climate.
Okay. Thank you very much. So that speaks even more about the importance of correctly managing our forests by knowing what's coming, not only increasing resistance and resilience to extreme events, but also managing carbon sinks appropriately. And we will hear in the second part of the morning about the importance of European forests as carbon sinks, and also about future scenarios. I think there's a question from the floor.
Thank you very much for this really interesting event. I'm Claire James. I'm coming in from the British Embassy in Rome. And I have a question for Professor Colin Campbell, all about, it really struck me when you were speaking that it's often said that we know more about space and the moon than we do about the earth beneath our feet. And soil isn't something we normally think about when we're thinking about the impacts of climate change. So when you mentioned also that if we just left forests be, in the sense, let forests grow naturally, that might be part of the solution. So this idea of not having invasive forest management. I'm just wondering how far that can be the solution, because clearly it must be a lot cheaper and easier to just let forests grow on their own. So I'm wondering why that doesn't happen so much. And how far that can be the solution. Thank you.
So thank you, that's a fabulous question, and to answer it, there are many people here who can talk about the silvicultural and forest management side, but I think there is a trend across all production systems, whether it's agriculture or forestry, that we have focused on production of the timber or the production of the agricultural crops. And we've adopted a very extractive approach with monocultures and even clonal material in some cases. And what we're not doing is exploiting diversity enough to have more resilient systems. And what we think is going to happen in the future is that we need to actually redesign diversity back into our production systems. We can let things go completely natural and we can rewild, and that will mean less productivity and less trees, less timber. Or we can take a middle approach where we try to design diversity back into our production systems. That will include soil biodiversity, and we are finding staggering things about the way in which soil biodiversity influences tree productivity, particularly with these symbionts, these mycorrhizal symbionts. They are connecting all the trees in the forest. They are connecting all the trees with all the plants in the forest, and they are signalling and actually cooperating with each other in the forest. And the more we learn about this science, the more options there are to design nature-based solutions to managing our forests in the future. So I think we need to change the way we think about how do we get more diversity back into our production systems.
Thank you very much. Yes, there's another question from the floor. Please.
Hello, my name's Wendy Wyver and I'm another representative of the British Embassy who have found this conversation fascinating. A number of the speakers touched in terms of solutions on the need possibly also to proactively plant tree species that are better adapted to the stresses of climate change, to replace some of those which really are failing to cope, such as, I think we mentioned, the spruces. But of course, that in itself will have an impact on biodiversity and the ecological system. While it seems like a great solution, particularly for maintaining soil, maintaining forest cover, what thinking is going to actually monitoring the biological and ecological impact of those changes themselves?
Thank you. I think I'll forward this question to Harald first.
Thank you. I can give it a try at least. I think we need experiments that are testing out the consequences of the use of new species before we actually then take the measure to say, yes, we plant them widely over large areas. And I'm aware of at least one of these experiments, which is a test planting experiment going on in Switzerland with more than 50 sites and about more than a dozen tree species. Not everything is planted everywhere, but there's a careful design behind this, what might make sense to plant in certain regions at certain elevations. And this is now being tested out. So I think we need research to figure out what should be done when and where, and not just start doing experiments in the real world by forestry, because we might regret them in the long term.
And then maybe, thank you, Harald, for the answer. And maybe Frank Hagedorn, maybe a perspective on the effect of tree plantations on soils, which we learned are very important.
I mean, I would back up Harald. I mean, I think so far we have a very limited understanding about the direct linkage of trees and microbial and fungal diversity in the soil. I mean, this is still a black box we are dealing with. And I mean, I think, we need this kind of experimental studies to better understand it, and also what it means then for the trees to grow on this kind of substrate. So there's a feedback between the trees and the soil organisms. And so far, I think we have a limited understanding.
Thank you. That's also clear in terms of where to focus more research, and also how to inform national policies that we hear more and more every day about planting millions and millions of trees, which have to be carefully done and carefully planned. We have a last question from online audience, so maybe a very short answer. The question is for Dr. Borut Vrščaj. It's about forest management in Slovenia. So Peter Iversen is asking, in the presentation of owned forestry in Slovenia, there were conflicting strategies for mitigation and adaptation. So will these be applied on different sites, or which strategy will you follow to compound these two very important goals?
Yes, you're right. These can be applied or should be applied to different sites. I would like also to add something to my previous speakers. It is true that research is needed, but there are some activities, some strategies that can be applied right away. I mean, changing forests from artificial pure spruce stands to more natural mixed forests is one of the strategies that for sure it will work. Or to limit heavy machinery to soils more resistant to compaction. But in terms of forest management, I'm sure that my colleague Aleš Poljanec would give better answer than myself. So if he can jump into the discussion, I would appreciate that.
Yeah. Hello, everyone. Do you hear me?
Yes.
Yeah, maybe I can give an additional explanation about that. So we wanted to tell that only maximizing carbon sink is not the right strategy, but it should be somehow balanced also with adaptation strategies, because if we maximize production cycles, then we produce more and more old forests, and old forests are somehow less resistant. So we should manage the forest, and in some cases where the risk is low, we could extend the production period. But let's say in case of spruce in lowlands, probably where the risk of management is high, then we should think about to reduce the production period. So, so it needs to be balanced to maximize, to optimize on the one side carbon sink, and on the other side a risk that we deal with through the management of the forest. So thanks.
Thank you very much. And if I can make a short conclusive statement, I think all the issues that we have touched upon this morning will nicely lead into the second part of our meeting. Forest planning and forest policies will be more and more important to correctly plan forest management that can take care about climate mitigation, adaptation, and prevention of natural hazards.